Hi, welcome to another video on my Arduino Mega2560 with electronics, mechatronics, motors, propellers, and since recently also the Arduino Uno. There are several things going on. First of all, yes, the Uno. The intention is to send from here some signal to here to the Uno. So from here to here. And have some LED going on. Last time it turned out that I first have to set the serial peripheral interface SPI into slave mode, and then it should be able to do something. Also, before I can send something, I have to make sure that I can actually write to them. Both Arduinos are attached to the computer via a USB cable. So when I look for them, and since this is Linux, it is quite easy to see. Right, ACM0, which is if it is right for the Mega, and it is root, so I have to change the ownership to my own name. And I have to do sudo a password, and that's it. So now this one can be addressed. The other one still has to go. So now they are both correct. I can close this window. By the way, another point is that for some time one of the two motors with a propeller has been refusing to work. I think that is due to some electronics, but I am not quite sure, so I will have to see to that as well. Now, what is going on? Last time I tried to send a message over, so show begin, and that was another point. I've had forgotten to put here show begin. Now the question is, how do I see that something is going on here? Well, quite simple. The show monitor, but I have to first select Uno, then the port, and that is in this case indeed ACM1. And now I can start the serial monitor, and it says signal is 1, and that is where I ended last time, because what do I send anyway? This is the setup on one thing, and in the real code I am sending the message, the digit 250, and 250 is certainly not the same as 0. So since signal is 0, the question is, how do I get that signal sent over? And that is a very good question. So that is one thing, finding out how it's done. However, according to information, this is the way to do it. So I have to find the slave side of the SPI to actually receive it. And that's as far as the introduction goes. I have found a slave demo. So actually my code should be more or less like it, and what I notice is that apart from this part of the code, which is nearly similar to this one, so I'll let this be, but I did not do this so-called slave init. So it calls slave init here, but I can just as well put things here. Now here they say MOSI, which is the same as master output slave input, and they use it as an input. So what I do is I copy this and say also the same, go to the end and then put it as input. Don't forget the semicolon because we are programming C now, and input slave output is also meant as an input, and the same goes for slave select. And in the example I used before this was not included, and I have the slave clock, which I suppose it means, and that is also the same thing. So let's just use this. As an input, and I think that is part of the culprit, because it has to know which is which. And then it says SPI transfer. Alright, yeah, that is typically a C construction where you put much used code into its own routines. However, this is not just a routine, or is it? Let's see. SPI transfer is used here. It is a function that is called. So yes, this is indeed just another function being called. But it needs to receive everything, and that is the hard part. So it says here pin mode MISO output, and that is different because here they say it is input, master input slave output, and they put it here to input. So that's interesting to see. Yeah, and as is last is something else. That is definitely a variable. It's a boolean. They set to low, and then if it is not equal to low, then put the pin mode master input slave output. So from from the Uno to the Mega to output. Then say slave enabled, receive SPI transfer. This is interesting. So the transfer of a digit is here assigned to this variable, and I certainly didn't do that. I just said, okay, well, I have a signal and that is something, but that is definitely not the case. So that I have to change. Let's try something out. After carefully studying some demos, which I have here under, it turns out that I made some mistakes. One of which is that you do not transfer just a number. This is a number, but not just a number. It is a specific number that is equal to a byte. In digital logic there are bits and bytes. One bit is either 0 or 1, and if you have a byte which is comprised of 8 bits, then that is the same as the value 255, and that can contain a number of values or any value. So a byte can be 1 and a byte can be 2 and a byte can be a lot of things, but it is still a byte. So this was not just a number. So whenever I was doing something with a high number and it gave an error, that was very understandable, because this number was not correct. So from the master you assign something, a byte, and which I have here assigned to some values. So say I want to say, alright, I send a byte, and then here I can say, alright, I just sent something, and here I do it. So transfer a byte, and then you just send it. So in this case I might say this. It is a byte, and that's good. Then on the other hand, here you have to receive a byte, which you but you have to transfer it as well. So here is the transfer, and here you do exactly the same. You receive it, assign it to an empty byte, and then if everything is alright, you can see which byte you are receiving. So let's just see if that works. The other point is, of course, that this will never work. So it I would say, if this is 1 and the other one is if it is not, so I'll still have to change this. But now I want to see if things are okay, so I am first let me first see if everything is selected. Yes. Compile. What is not declared? Yes, it is declared. Well, alright, let me do it to 1. That's one thing. Now I have to do for the Uno. Alright, that is done. Upload. And value. Then I have made a small mistake here. What is value? They assigned here byte is value, but here they say byte. Of course, wait. That is my problem. There you go. So it is uploaded. And now there's to see whether something works or not. And that is to be done with serial monitor. That is, if something works. Does it work? Board, port, yes, is to the Uno. I expected to see something, but apparently this isn't working so good. The serial print line doesn't do anything. Name for new file. Why is that? Why is that? Let me see again. Alright, I made a mistake somewhere. I have to test it. This is all alright, but I'm missing something. Well, that's the risk of experimenting. Alright, besides the SPI with communication between the Mega and the Uno, I want to have a little look at the electronics, because this is not to my liking. And then I mean the fact that this motor is not running, and even when I put the connector in, it's not doing anything at all. Now, some time ago I took out this inductor, so I am going to change this, and in that way I have to be a little bit careful. Alright, motor is offline, and what I have to do to check that this is the culprit, I'm going to move this wire here and put these two wires right in here. Now, if that is the reason, it should work now. And while this LED is burning, the LED or the motor, it's out again. Let me change the wires a bit. Very easily go out of the sockets. But again, no such luck. So now I put this motor on and it starts immediately. While this motor doesn't do a thing. And now there is hardly any difference between the circuits anymore. So the question is, what is the difference anyway? They are wired exactly the same now. Inductors here, there's an inductor here. Resistors all over. Transistor, LED. But this motor doesn't do a thing, strangely enough. So you may even tend to think that it is in this part of the wiring. Well, one way to find out is measuring. Let me quickly do that. If it is indeed in the wiring. And it is very faint wire. When I measure here, the voltage is very weak, and if I measure here, it is about the same. So the voltage is not the cause of the malfunctioning. What is it? Not sure, but it deserves a lot of thinking. And for the final part of the video, back to the SPI. Well, that was an electronic intermezzo, and unfortunately with a not very positive result. Another not very positive situation is that these lines are not appearing in the serial console, serial monitor. So I have put as a first line SPI slave, and checking again if everything is selected nicely. Yes. So I am going to upload it again. Alright, done uploading. Now, is anything visible? It is now. But that's it. There's a void loop, and that's all there is. So I'm going to change this a bit, and I put it right here. Here it receives it, and here it should actually print it. But will it? Alright, let's see again. Alright. Why does it say SPI slave? Am I missing something? Not really. So is this the culprit? I can disable it. Upload again. Done uploading. But again, this is not printed. So that is not nice. Am I making some error somewhere? Not really. This is byte. This is all byte. This is not what I like to see, needless to say. So, with this, unfortunately, another SPI experiment failed. But I am quite a bit wiser, and I continue with this next time. So, what did I do? Finding examples and making SPIs and making an SPI slave. Finding out that a number is not just a number, but actually a byte, which can contain several digits. And why this went wrong when filled in here, beyond me, because oh wait, I may be able to explain this. If this is declared here, it may work. It may just work, but that's for the other for next time. Strange is that this is printed and this is not. Very weird. We'll have a reason, but I will find out hopefully next time. Thank you for watching. If you like this video and you haven't subscribed yet, please do so. You can also follow me on Twitter and Instagram. If you like my videos, please consider a small donation. You can find more info via my website. And well, this is obviously going to be continued. Bye bye.